Hello guys, this is how to use the Thingiverse template. Say you want to make like a Bahamut Blitz brake blade or a Bahamut Blitz overblade, or like just any design you have in general. You can just come onto Thingiverse, you can search up Beyblade CX templates. There are a lot of them out there, but my specific one has every single part included, and includes the lock chip, overblade, blade, underblade, and the ratchets and the bits. Was it for the ratchets? The main part that you really only need to edit is the shell of it, which is like where it gives it the arms and stuff. And the height is editable, but it does take a bit of work. It is default as 60 heights. And the bit, it is a flat bit, but you can put whatever how many gears you want. You can make the base of the bit bigger if you want a super wide bit for some reason. You can just extrude it out and it can be a super long bit. I'll go into detail on that later. And for files, there's a summary for it if you want to read it. And then the files includes the F3Z, the STL, and then all of the individual parts if you want to download it individually. But it is recommended that you use the F3Z file. And once you have installed the F3Z file, you can come over to Fusion 360, which is the software I do recommend you use to edit these things. Otherwise, if you are using Tinkercad, it is a bit more difficult, and also Tinkercad's mesh calculation isn't as good as Fusion 360. Basically, what that means, I was showing a bit what that means, but when you can just open up the template, you don't need to touch any other parts. I forgot to show off the topology I was talking about with Tinkercad after I said, Tinkercad had worse topology. Basically, what that means is if I come to Utilities, click on 3D Print, and I select the whole thing, click on Preview. Oh, you can see that, oh shoot, this looks quite messy because I selected multiple parts. I'll just select one part instead. I'll select like the main blade and then click preview. What Fusion 360 does better than Tinkercad is these triangle topology it has on the models. It is a lot more precise than Tinkercad, and there won't be any gaps between the model, which will be important if you want to have a really precise model that you want to manufacture with. And STL, there's also the 3MF formats. It's just different for 3D file formats. 3MF is the best one currently for 3D printing, if I remember correctly. But yeah, it's just really clean. And Tinkercad, it struggles with high triangle count topology. And like, you can try importing this model into Tinkercad. It might work out, but then like some of the triangle vertices might glitch out. And that does happen a lot with Tinkercad. From experience, I have used Tinkercad before. But yeah, it is usable on Tinkercad with limitations, and just letting you guys know. The template is a assembly. It will include every single part within it, and you can edit in the context of the assembly, or if you want to edit a part individually, you will just edit it in the local context, which is like this little pencil mark. You can edit in place, and yeah, this is edit in place will be turned on. References are the components, and yeah, this you can just edit the part in here. So this is the ratchet shell. This is this part, the part with the arms that determine like if it's like a 260, 460, 660, and whatever. And let's see, the main thing someone asked was how to make a blade from Bahamut Blitz. So blade 1, and then now you are editing the blade. Let me see how Bahamut Blitz's blade looked again. Bahamut Blitz. This is 5 star-shaped kind of blade, right? All you gotta do is come in here, create a sketch, and select a plane. What this allows you to do is it allows you to sketch on 2D geometry to then transfer into 3D geometry. So you just click on here, click on the surface. What I did was I clicked the sketch onto the top surface of this template, and then all I needed to do is just make the shape of Bahamut Blitz. I'm not gonna go too in depth on like the I'm not gonna be too precise about this because I'm just showing off the templates, and you guys can customize it to however you want. I forgot how big the blade was. I never measured it. So I'll say that's like, there's the notch right there, and then a bit bigger is right there. If I remember correctly, that was like, I have it on here. There's the notch. Spec from here to here. Oh, that's selecting on the wrong thing. The spec from here to here, that's around 2.25 millimeters. This is working in the context of millimeters. If you want imperial, I'm not sure how to do that. I think you can just change the files, each individual files on what is it, measurement system to imperial if you do want that, but I did everything in metric. So let's see, bliss, that's like around, like I say double for the size. So right here, 1, 2, actually that's like right within the templates, right within the templates size. So where does it start again? I have to go back and forth. You're gonna need a good reference. It's best if you do this with like a caliper in hand, and if you're trying to like, copy like an existing Beyblade's design, it is best recommended that you get a caliper and the original Beyblade, and then you can measure from that original Beyblade. So that's from there to there, and then up there. So what I will do is make a circle right here, and then make a circle that goes all the way to the wall of the hole, and then you can use sketch dimension. What the sketch dimension tool do is it allows you to define the sketch's size. So you see, like, it'll have a bunch of zeros and then some decimals. That's like a very loose size. And it's not as precise. What you can do is use the sketch dimension, and it will define that dimension completely. So now, what is it? If a line is blue, it indicates that you can change the size of it. You can move it around, and it is best recommended like get as many white lines as you can, solid white lines. It means that they're locked in, and you won't be able to like move it around and accidentally mess up your entire design. So it was around double this size, 2.25. You can just do a very good feature in Fusion is that you can just do the math straight in Fusion, like 2.25 times, you can just do times symbol 2, and it will allow you to actually do that. And yeah, it looks like that my template actually is pretty much the size of Bahamut Blitz's blade. So you can click finish sketch. There's a little bit of excess. What we can do is use a extrude, and then we can select the excess and we can just cut it off. You see right here on the extrude panel, there's the profile, which is like the 2D shape that we selected. Profile plane, it just means that it's starting from the sketch. One side, it means that it's only protruding from one side. If you do 2 sides, it lets you extrude 2 different directions, but I mean usually that isn't really needed unless in a specific case. And the extend type is distance, and distance is -5 because we're cutting into it. Taper angle, you don't really need to mess around with it. That is more for like, what is it called again? That is more used for like injection molding. And then objects to cut, unless you have multiple bodies, you don't need to worry about this too much. And what that essentially does is allow you to cut like into one individual piece without modifying the other piece. And once you do that, it should be the size of Bahamut Blitz's brake blade. And all you gotta do is make another sketch. Usually I make multiple sketches, that's just how I work. But it is possible if you want to keep everything on like one sketch, but that gets a bit hard to organize at times. And let's see. Bahamut Blitz's blade. I'm gonna just loosely draw it out here. I'll make an internal radius. Now extend it out. And then it should be a perfect horizontal. So I'm gonna delete the coincident on that piece. Connect these 2 points together. And then this points can connect to that wall. And then you can drag and move it. Oh, see? This is an example of why you should anchor and define your sketch dimensions. See how this circle is moving? That is not what you want to happen, so let me redefine the origin sketch dimensions real quick. 32, and this one was, how much was that? 0.25 was it? Yeah, it's around double the size, so 0.25, 2.25, 2.25. Anyway, take a look at this again. Goes from here to here. I won't get it 100% accurate here just because I don't have the real blade with me. But yeah, let's see. Goes up and then around. Actually, it looks like it's running a tangent line across the outside. So let me try that real quick. What tangency means? Basically, what is it? This line. You see how this line connects into this circle? But these two are not like perfectly aligned. What tangent means is you can select 2 of them and then select the tangent constraints. What this does is center it so that the line is perfectly flat with like the edge of the circle. And that comes in really handy at times for design. You can do that. And then look like from the image that actually extends out, so I'll just delete the coincidence on here. Still a couple left. And yeah, now you can drag out this piece to create the blade. Let's go somewhat like this for the main blade. What is it? Delete the horizontal. What you can do to create the angle on that is select the 2. Oh, that was the circle tool. Use a line tool, and then you can get the 2 ends on here, and then set these parallel to each other. Oh. And then yeah, you can change the shape, and it will stay consistent. How do I do this? Let's see. To make it like a oblong shape. It does have a pretty weird shape. I'll extend this out a bit more to give it a bit more area to work with. And I'll set these parallel to each other. And this can attach to outside. Actually, yeah, that one shouldn't be parallel. It's only the top and bottom that needs to be parallel. And this, you can drag it to edit the shape to look more like Bahamut Blitz's blade. I'm gonna edit that to be in contact with the one circle on the inside that we had. Oh, it's not connecting the dots. Actually, I could probably just delete this line and have these two connect directly together. Yep, that works. And now you can just make the blade like this. It's probably better if we made this one horizontal. And then, yeah, here's the blade. Main blade. And then to make these smaller blades, I will finish the sketch for the main blade first. To make the what finishing. Another thing is, if you want to edit a sketch, you can just go to like the tree of like every feature, and then you can right click on the sketch and then click on edit sketch, and that lets you edit the sketch. And once you are done, be sure to click finish sketch, or else it won't save your work. So that's the main brake blade. We need to create another sketch on top of this one. I need to hide this sketch real quick, create sketch over here. And then what you can do is pull out the sketch you had from earlier, and then you can press the shortcut P, or you can come down through the features, and there's this project feature. I really like this one. And it lets you bring sketch entities from other sketches onto the current one. So like I just brought the internal radius and linked it to the sketch 2 one. So now if I hide sketch 2, we can still use the radius on here without needing to use sketch 2 by itself. So to make this smaller blades on Bahamut Blitz, I will just select all of these, create, project, and then I will project onto sketch 2. Oh shoot. Hold on. One important thing. When you're projecting, you can have the option to project with the link or without the link. If you're projecting with the link, it won't let you edit the size of things, because that is like a direct lock on between the two things. If you do non-projection link, it will just give you the lines without the constraints, and you can edit the size of them more easier. So I will now hide sketch 2 because that's everything I need from there. I will parallel this and then set these parallel to each other. That doesn't seem right. Oh yeah, that's because it wasn't constrained on there. If you do like do projection from another sketch, be sure to like redo the constraints on it. Otherwise it will just, like you saw earlier, flop around. So I will set that horizontal for now, and then set these parallel to the horizontal. Whoops, I set that one to horizontal instead. Let's see, I will fix. What fixing it does is basically anchor it temporarily, and then you can disable the fix later when you do need to. So parallel, click on the line, click on that line, and it makes that line parallel to that. And then, I'm not sure why that isn't parallel. That's odd. For two lines right next to each other, you guys can also use collinear. That just basically means that the two lines will have to be in line with each other. And then you can edit the size of it. Let me pull up the original blade size. I want this to be just slightly smaller than the main blade. That's how Bahamut Blitz works. Like I said, I won't go into like too much detail, since this is mainly a tutorial for you guys to just show you how to use the templates. And then yeah, there's the two sketch profiles that we need to use. So now I will hide the smaller blade first, and then for the big blade, we're going to click extrude, and then we're going to select the pieces we want to create extrude on 2D geometry into 3D geometry, and then we can just click down here. If you don't want to measure it, you can input the measurements just manually, or you can also click on something in reference and it will do it automatically. So there we go, that's the main brake blade. I'll just click OK. And then to make these smaller blades, what you can do is go into the sketch. Oh yeah, if you can't see anything when you edit sketch or like edit a body, it probably means you click on this little eye symbol. It means that that feature is to hide and show the different items in here. So I'll quickly delete that horizontal constraint. What that does is basically keep the line like perfectly horizontal. And then in the features, there's a thing called circular pattern that you guys can use. And then you guys can just click on all the lines you want to make a circular pattern of. Select these center points. And Bahamut Blitz has 5 other subblades. Finish sketch. And then extrude, you can select on all of the circles. And then you can click down here. And yeah, see, that looks, I mean, it's alright. I mean, it's somewhere there. Like I said, I don't have like the most precise measurements, but yeah, that's basically how you can make like a main blade using this template. And then you can use the chamfer to make it look even better. You just have to select like every single edge on here. It is more of a manual process for this, but it is at least better than Tinkercad, where you have to make a bunch of right triangles and then put them along the edges. Usually a lot harder. Let me just select the edges really quickly. And then once you do that, you can set the chamfer size however you want to. This is a 2mm chamfer. This is a 1mm chamfer. Bahamut Blitz has more of a side profile. Bahamut Blitz has more of a 1mm. This is more of a basic shape. Kind of sick, sorry about that. But what is it? Bahamut Blitz's blade shape does taper down a bit more. And what you have to do here is more of a lofting cuts or a different type of extrusion. But what is it? Using a CAD software like this, everything is just extrusions in the end. So I'll just do like 0.5 just as an example. And then if you wanted to do the lofting cuts, let me find it. Or actually, let me test if this works. I can just select 2 edges on here, and then instead of a equal distance chamfer, I can do like a 2 distance chamfer, and that lets you edit like how far one goes and then how far another one goes. So 1mm chamfer downwards, and then how about 6? Nope, 6 is too much. 5 is also too much. Why is that? Oh, it was doing this asymmetrically, so I have to do this one edge at a time. It looks like 1mm, 2. I'll do 5. 5 works. 9 works. 10 10mm chamfer, and then I'll probably go like, actually, I'll just do that for now. So yeah, 10mm chamfer, 10 by 1mm, 10, to clarify, 10 by 1mm, and then 1mm down, 10, nope, that was a vertical, switches these around a lot sometimes, so beware. 110, and that creates the blade profile. And then to make it more refined, you can just come in here, select all of the edges that you just made, and then you can do a secondary chamfer. 2 is too much. How about 0.5? 0.5 millimeter chamfer. And hey, that looks a lot better than earlier, which was just a blocky shape. See how it has this tapering shape on the blade? A tapering shape on the blade. And then, yeah. This is the view box. And it's kind of similar to Tinkercad. If you ever use Tinkercad, it just lets you pivot around stuff. And pressing the home button resets the view, and then you can like spin your Beyblade in here, I guess. But yeah, that's how you get the blade. If you want to change the color of these things while you work on them, you can click A, the letter A on your keyboard, and this lets you pick from a selection of materials that's Fusion 3, Autodesk Fusion. They don't call it Fusion 360 anymore. They call it Autodesk Fusion. I can't believe it. But but it lets you change the different materials in here. Like I can bring out ABS, just as a basic plastic. There's also nylon 12, which is usually what you print these parts with, using Gelsey 3DP, not sponsored. And there's resin, tough resin with Formlabs. That's also one you would use. Say, well, main blade's got to be steel. So steel, you can edit the color of the steel. Like maybe give it metal coat, I guess. You can also let's give it cobalt metal coat. How about that? Cobalt metal coat. And then yeah, and then once you're done editing the part, oh, I need to get some water. Once you're done editing the parts, you can just click on finish editing, and then it will save this into the assembly. One thing cool about assembly is you can actually pull out the parts individually, and then you can take a look at them like in more detail if you wanted to. You can even hide the other parts by clicking on the eye icon, and then you can get a more detailed view on your parts. And if you ever want to return your parts to their original place, you just click on here, revert position. Do not click on capture position, because that just means that it will set the new position where you move them to as the new position, and then if you click on revert position, it won't return them to the original state, like this. So now, Bahamut Blitz Overblade. Let's see, where is the overblade? This is the overblade. Click on the pencil to edit in place. And then for the overblade, what you can do really simply is create a sketch on here. And then to very simply get the outline of the shape that we wanted, we can... This is the easier way out. Normally, you should probably sketch it out, but I'm just doing this quickly. You can select all of the faces on the Bahamut Blitz blade you just made, since the brake blade is kind of similar, right? Brake blade, brake over blade. There's the blade, there's the overblade. It is kind of similar in geometry. It does taper down a bit more, and there's a larger circle area underneath it, but I'm not going to worry about that too much. You guys can get into the details if you want. But there's the projection. I'm not going to link it because I actually need to edit the geometry of this line. So all I'm going to do is remove like any excess that I see. Well, delete, okay, and delete, connect everything together. And then what you can do to make like a copy of the shape is using the offset tool. Oh, the offset tool. And the offset tool only works with one continuous line, so I gotta remove the insides of that circle again. Offsets. Why isn't it working? Chain selection. Hello. That's odd. It's not letting me do it. Oh, finish sketch, and I'll just make a second one using that sketch as a reference. Project, and I will select, because I think because I selected the faces, I got multiple copies of one line overlapping each other, and that's why it wasn't working properly. So with this, hopefully I will just select one continuous circle, or I guess Bahamut Blitz's blade shape, and then I can, where is it? Offsets. Hold on, that top blade isn't connected. Yeah, see, these two were not connected. You use coincidence if you want to connect two lines together. You just click on the ends of the two lines, these white dots will show up, and you can use the coincidence restraint to connect them together. And offsets, just let me select. Why doesn't it let me select the whole thing? That is so odd. Let me try disabling the previous sketch. Oh, you just let me select both of them, I guess. So then what this allows you to do is, as you can see, create like a shape from the original shape, and you could just shrink it down to the size of the brake blade. That was around this big, I think. I'll just call it -3. And yep, there is the brake blade shape. And then it's the same thing with the overblade. You could just select the profile, right? Hello? Where is this? Define sketch plan right there. Okay. And then yeah, you can select the blade, extrude, click on the main blade, and this will just extrude down all the way to the main blade. And yeah, see, there's your overblade. And you can get into like more detail, like what I shown here earlier, changing the angles on here using the chamfer tool. And there's a lot more tools that Fusion 360 offer compared to like Tinkercad or something. You don't just need to use boolean cuts. And yeah, this is basically a more advanced version of Tinkercad if you think about it. And yeah, that would be like a Cobalt, I don't know, Cobalt Blitz or something. And yeah. And yeah, that's basically how you use the tutorial. Should I do a ratchet? I guess I'll do a ratchet. I got time. Ratchet shell. You can edit the ratchet shell. This one's a slightly more complicated, but should not be that much harder. You just edit the ratchet shell. If it's hard for you to visualize all of these, I did model out every single part, so you could just hide the ratchet lock, hide the ratchet's bottom, hide the bits, and then hide the blade, the overblade, underblade, the innard. And then this makes it a lot easier for you to see if you are having trouble visualizing it. So the ratchet's bottom is around 30 millimeters. And then from here, I will make an external size of, let me get my caliper out. I have a 160 ratchet on my table right now. Let me just get the height, actually not the heights, let me get the width of the 160 ratchets. You would just take your caliper, make sure it's zeroed properly, set it in millimeters, and then you would just take the caliper and the ratchet real quick, and then measure out how much further out it goes. It's around 1.5 millimeters, so right there. I'll measure from here to here. That is 1.5 millimeters. Finish sketch, and then Ratchet shall extrude from here to here, and that will create that. And then if you want to make a 160, for example, you would just create another sketch on top. Since we already have the outside geometry, we can essentially use the line tool, come out, and then you can create a mirroring line. What is it? For the mirroring feature, you have to select a feature that you want to mirror, and then also the line you want to mirror on. So this is like basically you can define which part you want it to be reflected over. And then once that's done, this is like a mirror of that line. So see, they move in unison. You can do this to tangent it, and then both lines will be tangents. And then 160 comes out a bit slightly, and then you can use a 3-point arc from here to here and tangent that, and that's like a really basic 160. You can go into more detail if you want, but that is all the detail. I'll make it more accurate. I will use my caliper to measure how much the 160 arm protrudes. It is around 4.5 millimeter, very rough estimates. I'll go into the sketches. I'll select the sketch, edit sketch, and then 4 millimeter. What you can do is create a point that is a coincident with the arc, and then measure from the arc to from the surface. Whoops. I also need a line on there. I mean a point on here too. Point right there. Point. Set it to this. Oh. Now what? It's easier if you just use a line. Drag a line out to here, and then from here to here, measure. You want 4.5. And then if you want it a bit beefier, you can make it more narrower, beefier. Depends on the shape of the arm you want. And you can finish sketch, and then click on extrude, and then you can click down here, and that will create the 160's arm. And then once you re-enable and unhide every single other parts, you'll be able to see it in a bit. Finish sketch in place. There is the 160, and what is it? I modeled everything in this template off of each other, so once assembled, this is the way the 160 will be facing. So you can edit like on the shell where you want the 160 arm to be relative to your main blade position, your overblade position, and your underblade position. The underblade, I'm not going to go into a tutorial for it because it's basically the overblade, but copied again. I did make like a larger surface area for the underblade, so you guys can add a bunch of gimmicks to it if you want. If you don't want such a big underblade, I mean technically I did just caliper a normal CX underblade. They're the same size, so normal CX underblade, 5.25 millimeters around that. This was area loop. Nope. And select the top line. Alright, this is the measure tool. I'm just like going as I go. So the measure tool, it lets you select two things and measure between them. Usually works best with like a perfect circle and a perfect line. So if it's like some weird arc or protrusion, it has a harder time measuring it. So right there, 4.5. That was actually a bit small. It was. Never mind, my caliper was a bit off. It is right around 4.5. Because, what is it? The connection points of the ratchets that Beyblade X uses. Let me see. Underblade, ratchet inner, ratchet shell, ratchet lock. You see this part where the ratchet slots into up here and then twists into here? The extension comes all the way out here. And yeah, that's how you edit the underblade if you were to edit it. And then Beyblade X bit. You can make a bit however you like. Since this is like a Bahamut Blitz tutorial, I'm gonna do like ignition bit. Bahamut Blitz. Ignition. I don't know how to spell. Ignition. It's a good image of it. There it is. A good image of ignition. Or if you have the real ignition bits, you can also just model this straight into Fusion 360. It looks like it comes out all the way to the wall. So, create sketch. The gears. How many gears is on this thing? 1, 2, 3, 4. I'm just counting from like half circle to half circle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll select 20 gears on this thing. So, very roughly, since I don't have the real part with me, so I can't use my caliper to measure exactly how much it is. I'll select 10 millimeters, and then to create the gear teeth, I will create a line, and then similar to what we did with the 160, you can just use a line like this, and then mirror this piece over. Whoops, why is there 2 selected? You can mirror this piece over this line, which will create a mirror copy on that side, and then these. I'm not sure about how big the teeth are, so I'm gonna just use a ball bit that I have on my table right now. 1.2, 1.5. The bottom distance is around 1.5 millimeters, and then it tapers down to a 1 millimeter distance. So this will be 1 millimeter. And then you will use like a 3-point arc to make. If you want rounder teeth, you can use a 3-point arc. If you want sharper teeth, you can use a straight line. If you want slightly sharp teeth, you can just edit the geometry of the teeth to whatever you want it to be. This is just how expansive the template can be. So I'll just make rounded teeth, and then I want it up against there, so I could just press P, project, select that edge I wanted to use, and then it'll create a copy of it on here, and I can use the measurements, just set the measurement right there, just so, oh, yeah, what is it, projections, they don't link to the origin, so if it ever comes out of place from the projection, you could find the center point of whatever it was, and select this in the origin, and then you can use the coincident to attach it to the origin. So this against the wall will be tangent, and now we have the shape of our gear for the bits. We'll create a circular pattern objects. I will select this, this, and this. Center points will be where the pattern will revolve around, and then this. You can select partial if you want like a gear, if you want a geared bit with only like half the gears for some reason. That might actually be a pretty cool gimmick. There's like this one episode in the anime where like Crosshair X goes to like a underground battle arena. Oh well, that's going off topic. Quantity 3 to 20. 20, actually 20 gears is a bit more, it looks like. Maybe I'll just do 18. Because Beyblade X, they do need a gap in between the teeth. And since I don't have the real ignition bit with me, I probably counted it wrong. I could do 14. And then finish sketch. Once you're done, all you gotta do is select all of the faces from which you want to extrude from. And then once you select that, set the distance. Measure from let me find a flat bit real quick. I have a geared flat, and I'm measuring about 5.8. Was it? I'm using my calipers. 6.25. Around 6.25. 6.25. Okay. And then you would create the main bit by making another sketch. And then the inside of the ignition bit, let's see. Yeah, it is the same size as the wall, but it has this weird castle-like pattern. I'll show you guys how to do that. Let's see, 10 millimeters. Make sure you anchor the size to 10 and define the geometry. And then I'll say like it goes in by 3 millimeters. I'll say 3 because 3D printed parts are just weaker in general. Compared to injection molding, 2.5. I'm going off estimates here. I don't have the real bit. It is around half of it. So maybe 2.75? 3? Yeah, around 3. I'll just call it around 3. And then there was the little walls that connected. I'll just do a center line from the middle, and then I can mirror these two lines over this line that I just made. Beware the measurements, not measurements, the sketch dimensions. Measurement lines are white and they overlap sometimes with maybe a line or something. You can also move the measurement around and it will just point to wherever it is. You can move out the way. So now that that is mirrored, you can like change like where it is. Should set these not parallel. Where's collinear? Does not let you do collinear if it's not full connected. No, collinear's right there. Wait. Yeah, so you can change the wall size of the little bit that's inside Bahamut Bliss, but I'm just gonna go with a solid measurement, so I'll set this to like 1.25 millimeters. Yeah, it's around that, 1.25 millimeters. And then I'll show you the walls of that part in a second. Let me finish the sketch. We have the shape of the bit that we want. Extrude. We'll do one extrusion. I don't know how big that is. I'm gonna just go off of the flat bit that I got. Where is it? Oh, gosh, sickness is killing me. 4, around 4 millimeters. 4 millimeter, okay. And as you can see, once we did the extrusion, the sketch does automatically hide itself. But if you want to reuse the sketch, you can always just come into the tree and then you can find the sketch that you just used and then you can re-enable it and then you can do a second extrude with it. So that was around 4. I'll do like a 3 millimeter extrusion to create that internal structure that the blitz bit, that the ignition bit has. Yeah, ignition. And then yeah, that will create like the flat section. And then to create the grooves that the ignition bit will have, you could just there's multiple ways to 3D model, and you guys will come across your own way of modeling this and your own processes. I'm just showing mine. I will project, and then I will create a midline, an offset line, and then define my geometry. Gotta always remember, gotta define your geometry or else they will go off. And yeah, this is not anchored to the origin. Let me anchor this to the origin. Whoops, I like that. Where's the center? There we go. That will be anchored to the origin. Everything is anchored now. I will mirror align this object to mirror this. Okay. How big is the little grooves? I'll say around like 1.5 millimeter around what the struts were. 1.5. There you go. Finish sketch. And then you see we have that little piece of geometry. We can. Uh-oh. It looks like the mirror line wasn't connected. Mirror line? Hello? You got a coincident on there. It was probably off by a tiny bit. That's why it wasn't. Yes. Now you can select as a face. Extrude will go in by like point. We're going into the geometry, so negative 0.25. That's not enough. Negative 0.5. Could go higher. Negative 0.75. Is that it? Yeah, that's right. Actually, this one does have a tapered angle on the inside. So my sketch on this was not accurate. Instead, I think a better way would just be, since it's tapered on the inside, it's not like a square shape. You could just take the extend a line from the center of the origin out to the outer perimeter, and a sketch dimension from here to here would be like 4 degrees. Nope, 4 degrees is too low. Actually, I don't need to be going off of degrees. I could just lock this line in place, and actually, I didn't even need to lock that line in place. What am I saying? I'm getting a bit lost. Object, mirror line, okay. The distance between the outside one. There's, oh, no. Yo, let me select. So let me select the coincident. Okay, coincidence. Sketch dimension 1.25. There we go. Finish sketch. Finally. Extrude these two faces. Negative 0.75. Okay. And then chamfer this and this edge by 0.75 because when we went in by 0.75. Actually, the one on ignition does seem a bit sharper. So you could probably do a 2 distance and reduce the one of the distances to like a smaller distance. And then, let's see, to make it a bit smoother, you could do like 0.25. Nope, that's way too much. 0.15. Actually, you could just use a fillet on here. A fillet is a curved cutout on the edge, and then a chamfer is a sharper cutout. That's the simplest way to put it. 0.15, and then 0.15 on the inside. Loading. And then you see like that creates that smooth geometry. That would be probably better for a attack bit. So what we can do now is create. In the sketch, you were able to use something like a circular pattern, but you can also use a circular pattern outside the sketch. And instead of the sketch entities like the lines, we can select faces, components, bodies, or features. In this case, we will be using features. we're gonna be selecting the extrude down and the chamfer that we did on the side. And then for axis, instead of letting you select a center line, it tells you to select the axis of rotation. You can create more axes if you need, but for this case, since everything's streamlined and everything's lined up on the center, you can just come to the origin file and select the z-axis, so you can determine how many of these little teeth that you want. How many is on the ignition? 1, 2, 3, 4, 5, 6, 7, 8. 8 cutouts. Okay. Oh, see error 1 pattern. Compute failed. Could not be created at the request size for adjusting SD. It's going to develop chamfer could not be created. Interesting, there appears to be an issue with the fillet chamfer, so I will try feature, access, origin Z, object select the extrude. I will do 8. Oh wait, I think it's because I didn't put it on optimized. Was it identical? It will try to use the exact same geometry, so you would have to roll back the timeline. Oh yeah, here's the timeline. It basically shows you every move that you ever did, compared to like something like Tinkercad. If you save the file, it erases all previous history and you cannot go back to a previous version. But this, it will allow you to like drag the timeline to a previous timeline. Oh, see pattern. Why is it doing that? I think it's because I did the fillets on here that did that. So you can see I can roll back all the way to like the beginning, and then I can roll back to like before I did the 2 chamfers. And then circular pattern, place of work, object, X ease, origin Z, full, optimized. 8 of these cutouts. Why is it doing that? Do I need to select the faces? Feature. Should be feature. This axis, origin Z, full, identical to optimized, 8 of these, okay. Oh, now it worked. I guess Fusion 360 just had a little bit of hiccup, and you had to just work around it. And there will be the chamfers, not chamfers, fillets. Fillets, they're different. And then you can see it creates the ignition bit. And is the ones on here taper? Yeah, you see how like the gear teeth are angled downwards, probably to have like a better connection with the extreme line. You could just come down here, chamfer, select all of these, or you could do one in a circular pattern, but as you see, circular patterns are usually a bit finicky. And then that was how much out again? I'll just set it to 0.15 for now because I need to check real quick with the measure tool how much the distance from here to here would be. 1.5. Got it. So edit feature 1.5, not too distance, equal distance. Could not be made. How about 1.449? Yep, that works. Sometimes Fusion doesn't like absolute geometry, so there's a little bit of divot left right here, as you can see with like the cursor and the lines glitching a bit, but that is perfectly fine. And there is the ignition bit, which is made. Oof, seems a bit higher than the original ignition bit, I think. Yeah, this image, I don't think I used. Well, I mean, we could just come into the bits and then find the extrude that we did for, yep, this one. Find the extrude that we did for this one. Maybe switch it to 4 mm, way too small. 4.5, 4.5 mil. There, yep, that ignition bit looks a lot normal now. Like I said, I don't have the exact measurement, so I'm just going off by like looks. There's the ignition bit's bottom, there's the internal, and then there's like the gears for it. And then if you want a more precise look, you could hide everything else. And yeah, there's the ignition bit. If you guys want to make this a free floating bit, hold on, actually that's pretty important. If you guys want to make a free bit, you gotta find the one extrusion I did in here for it. Was it this one? Feature. Yeah, it was this one. If you guys find this extrusion in here, you could just set this to 2 sides, and the other side would just be pulled down to there. Click OK. Wait, I did something wrong. Oh, that wasn't the extrude. It was this one. It was this one. Instead of having all of these teeth, I actually edit the sketch real quick. Editing the sketch, there's the teeth for the inside of the bit that connects to the ratchet, so I'll just create a circle right there. And to make this a free ignition, imagine free ignition, we just come here, find the extrusion again, and then we can deselect the gear teeth faces. And then connect that back up. And yeah, that would be a free bit, free floating, free spinning bit. Pretty interesting. I mean, the more you use Fusion 360, the more you get used to it, and it is better if you want to get into like more advanced 3D modeling. It's a lot better than Blender. I tried learning Blender, but it doesn't have the same concrete and anchored feel as like a traditional CAD software like Fusion 360 or even SolidWorks. SolidWorks is a lot more professional and there's a lot more stuff you need to look out for in SolidWorks compared to Fusion 360. Fusion 360 is more of like a forgiving one. So yeah, that is about the tutorial, right? What else did I forget? Well, maybe I could do like the lock chip. I mean, the lock chip is just literally one sketch, and then you can make the internal radius for it. You can change the size of the sticker if you want, or even like if you want a hexagon face bolts, like the metal series. You can Mr. creates polygon in describe create center point of vertex edge polygon. Yeah, there you go. There's a hexagon. You can create a hexagon and then just extrude negative point for how much it goes in, if I remember correctly, for CX log chips, it was around 1 millimeter. Just measured it since I have a CX bay on my table. -1. There you go. Looks a bit dark. I will change the material to white so it is easier for us to see. And then, if you want to make it fancier, you could do a chamfer. Just select the inner edge of it. Wait, not the face. Come on. Inner edges. And then this will have to be a 2 distance one. I mean, it depends on what you want to do, but you can just modify this however you want. 0.25, and then the height will be like 1. Nope, That was the other way around. 0.25 inwards, 1 outwards. I can make this a bit more exaggerated so it's easier to see. 0.5. And yeah, see, that's like a hexagon. You could fit like a hexagonal sticker in there, like from the Metal Fight series. And then if you want the exact measurements of this hexagon, you can use the measure tool. Like if you want to make a custom sticker for it. Is 13.856 millimeters, so you would just make a circle of 13.856 millimeters, and then you can measure each side of the hexagon, which would be 6.928 millimeters. So how you will make a sticker from this is just create a circle of the far length of the hexagon, and then if you want the no, and then you would use like a ruler to find 6.928 millimeters on the ruler, and you could just trace around that circle and it will give you like a perfect hexagon if you want to cut it out by hand. Yeah. That is mostly it for the tutorial, I guess, of how to use like this CX Blade templates. And you just gotta know how to use this real basic modeling software, and then you can make something pretty cool. So yeah, thank you.